This is Algebra 2, Lesson 12.3, period. So we're going to investigate on the calculator again different changes to our graphs. So I'm going to use cosine this time instead of sine, but the effects are the same for both sine and cosine. So on my calculator, I am going to change my window so that we can see a little bit better, but I'm only going to be looking at the positive side of the graph rather than both the negative and the positive. So my first equation says put in cosine x and then put in cosine of 2x. So cosine x is really the same as cosine 1x because we have that invisible 1, and then cosine of 2x, and putting a 2 in the parentheses instead of out in front of the parentheses like last time, what we think will happen now. And here's my standard cosine x, that is one complete cycle of cosine. Starts at 1, goes down to -1, ends back at 1. Cosine of 2x completes 2 cycles. There is one cycle here, starting at 1, down to -1, and back up to 1. And then we have a second period right here. So the value that we put in with the x modifies the number of periods or the number of cycles we see. Cosine of 1x, or just x, gave us one cycle in a setting of 360 degrees. Cosine of 2x gave me 2 periods in 360 degrees. So let's sketch this. Here is one cycle, cosine 1x, and then 2 cycles in the same 360 degree window. So cosine of x, one cycle or period, and cosine of 2x had 2 periods in the same window. So when I put 3x on there, if we predict what's going to happen, and so there's my cosine of x. My cosine of 2x you can still see when I drew it, and cosine of 3x ends up having 3 cycles. We have 1 here, 1 here, and 1 more right here. So whatever value we put in the parentheses with x, that's going to show us the number of periods in a full circle in 360 degrees. So I could put 4, 5, 6. The number that I put in there shows me the number of cycles I see. And then if I want to calculate the actual period, what I'm going to do is period would be the length of one cycle. So I'm going to take my 360 degrees and divide that by the number of cycles I see, and that will tell me the length of one period of my functions. So, first example says identify the period. I'm going to do a little bit more than that. I'm going to sketch a rough graph. So I know sine of x would have one cycle in 360. So sine of 2x is going to have a cycle that ends here. It's a lot more bunched up. And if I wanted to get the period, I'm going to take 360 degrees, which is one normal cycle, one normal circle, and divide that by 2 because I can fit 2 circles in the same amount of space. So the length of one period would be 180 degrees. think I'm just going to do the right side on this one because that got really crowded on the last one. So a regular cosine looks like this. And if I can only fit half of a cosine in the same amount of space, I'm only going to see the first half of it. I didn't even finish the other half in my 360-degree window. So 360 divided by a half, and you can do a half as a fraction or a decimal, means that it takes 720 degrees to finish one cycle. The next one shows me a graph, and I can count these cycles pretty easily. Starting at the center, I have 1 cycle, 2 cycles, and 3 cycles. So my B value on this one is 3, and if I wanted my period, I do 360 over 3 to get 180 degrees. So the length of one cycle right here, that is 180 degrees. I want to go a step farther and write the equation for this graph. So we should know by looking at this that this is a sine function. We did that on lesson 1, where the graph is centered, that's a cosine. It covers the graph, and where the function slides through the origin, that's a sine graph. So this one is sliding through, it's not symmetric, this is a sine. I figured out that my B value is 3 because there were 3 cycles in my 360-degree window. My horizontal center line is way down here, so that is at -2. That is my vertical shift. And if I go from the top to the bottom, that is a total vertical distance of 2, but half of that is my amplitude, so my amplitude is 1. I can put a 1 in front if I wanted to, but I'm just going to leave it blank because I know that an invisible 1 is there when I don't put anything in there. And that's the nice thing about the graphing calculator, is I can always check my answers to see if it matches the picture. Sine 3x minus 2, and we'll zoom to a standard trig window, and that looks like the exact same graph. That's it for the notes on this lesson. Good luck with the exercises, and please let me know if you have any questions.